welcome to a special edition of Crawford County Outdoors. I'm Dwayne Kohler, and typically whenever we have a do-it-yourself project, it's me doing it with some helpers. Andy Alm is joining us today to talk about blacksmithing. Andy's been with us before. We talked about hunting knives. Andy makes custom hunting knives, but he starts from scratch. So I'm really looking forward to seeing. He's actually going to demonstrate how to make a knife, and we're going to have some other folks join us that are interested in hearing about that too. So I think this will be a very interesting show. So stay tuned.
Andy Alm is our speaker today. When we were kicking around ideas for the fun part of the Ask the Expert series, one of the first things that came up was blacksmithing and welding, and some things like that, really different. So I thought, let's give Andy a call. So Andy and I first became acquainted when he was working locally here with local media, and he left that to go kind of full time into this business. So Andy, we want to have you give a little introduction to yourself. But he brought gear outside, so we're going to have an actual. So sparks are going to be flying here. We're going to have an actual demo outside. So Andy, introduce yourself and tell us about how you got into blacksmith.
Well, thanks a lot, Dwayne. Again, my name is Andy Alm, and I'm a blacksmith, knife maker from Pittsburgh, Pennsylvania. Used to work at the radio stations here, the Forever radio stations here in Meadville for about 7 years. I did that. Before that, I worked for Joe Vilke's station for Cool 101.7. Did that for a while. But I've been doing this work since probably I was in high school, just part-time, just kind of a hobby, selling a few here and there. And probably about 4 or 5 years ago, I got so busy that I basically had to quit my job. I'd been building my shop at that point, and now I have a, pretty well-equipped shop, and this is what I do. So, this is pretty off the cuff. I'm not totally prepared for everything here, but I want to show you what I do, show you some of the different knives that I make, explain some of the processes. As Dwayne said, we've got the little forge out there. I mean, very, very primitive setup out there. But I want to show you too that you can also make knives, make whatever you want. You don't have to have a really fancy setup to do this kind of work. You can get stuff from a garage sale or stuff from Craigslist. If you know what you're doing, it's really a lot more about the skill and the handwork and the knowledge than about the fanciest tools that you have. So I want to show you here before we break to go outside. I've been showing you some of my work here on my Instagram page. As you can see, I have a reputation for using railroad spikes. Almost all the knives that I make are using railroad spikes. Now, some of them are just spikes. Some of them are larger knives where I'll use the spike as the handle, and then I'll forge weld additional steel into that blade, almost like a Damascus steel process. If you know anything about Damascus steel, I'll be explaining a little bit more about Damascus later on, but it's the same kind of process. In fact, now I'm even making my own railroad spikes out of Damascus steel. Why? Because I can. I like to think that I'm the smallest manufacturer of railroad spikes. This year I made 10. Next year I hope to double that output. But I challenge you to find anyone else who is making railroad spikes out of Damascus steel and then forging those railroad spikes into knives. So that's something else that I do. Again, why? Just because I can. This is my Instagram page. I'll show you one quick video. I don't want to stand here and talk and bore everybody to tears. I want to show you a little bit of action. I don't know how far I'm going to be able to get with the lighting out there and with the primitive setup, but I'll show you some things. I'll try to answer everybody's questions and show you how you too can do some of this work, make some blades for yourself. Also, probably ought to mention, I was on the History Channel's Forged in Fire. I was on season 3, episode 3, Pittsburgh, Pennsylvania. We did the butterfly swords. I was the runner-up. I lost in the final round. I like to think on a bit of a technicality, but the winner, he totally deserved it. He was awesome. He's been doing this longer than I've been alive, Mr. Shane Carter. It was a very good experience, got me a ton of publicity. I've also had an article written about me in Outdoor Life magazine a couple of years ago when I just got started into this stuff, and then Mr. Dwayne also had me on his show a couple of years ago as well, which was always a blast. Always love working with these guys. They're awesome. So take a look at this, then we'll break and we'll check out some action outside. Here's some different things that I'm doing. So let's move outside while we still have a little bit of sunlight. I'll show you some basic things, and then we'll come back in here, wrap things up, and answer any questions. Anyway, this is pretty, you know, laughably ramshackle the way I have this set up. I don't even really have an anvil here because my anvil is like bolted to a giant stump, and it's difficult for me to haul in my Subaru. So I had a little section of anvil that was actually made from a railroad track, but it was actually shaped like an anvil. It had a little horn on it, and I thought I loaded it up this morning, but I did not. So I found this, and this will be my anvil today. But it's literally all you need. I mean, this is literally garbage equipment. You can get the stuff anywhere, and you can do pretty decent work. You know, I can't match the quality. I can't match the quality here that I'd be able to do at my home shop, obviously, but, you know, I just want to show you guys that anybody can do this with a very minimal investment. That forge is the most expensive thing I have. This is a propane forge made by Majestic Forge. I will go on the record by saying this is a terrible forge. About $450. It's garbage. I had a gas forge prior to that made by Diamondback Iron Works that was freaking awesome, and it got very hot and it was very fuel efficient. This does neither of those things. It is a piece of garbage, but it exists, so we're going to use it today. You can actually build a better forge than this if you don't mind the mess. Build a coal forge. Build a coal or a charcoal forge. You can use an old toolbox or convert a barbecue grill, run some pipe out into there, drill some holes into the end of the pipe, and build your fire in there. You know, dead simple stuff. So I have, this setup's obviously pretty small. I can't do anything really too impressive here, but I brought some mini spikes, which is what we're going to try to work with here today. This is they call it a dog spike. This is used on the little tracks that run in the mines, little underground mine cart tracks. So we're going to try to smash on one of these. I was practicing a little bit earlier, so just to save a little time, I started smashing one down just about half an hour ago, so we'll finish the job on that one. And we'll see, you know, I don't know how much grinding and finish work I can show you. This is pretty small, but I'll show you when we go back in. While we were setting up, I actually set up here in the parking lot and did a knife start to finish in the parking lot. So it's my parking lot knife. It is not good, but you can check that out. Anybody have any questions? Anybody have any, you know?
Do you have a preference, gas or coal?
Very good question. I mean, I use gas for what I'm doing with spikes. Kind of the convenience of it. Depends on what you're making. This works for me for most of my stuff. There are times when, and I do have a coal forge too. There are times when I'll use that when I need a really high heat, like if I'm doing a lot of forge welding or if I'm making Damascus, I would go with the coal. Like I said, this forge is kind of crap. You can just barely make Damascus in it. It won't get, my previous forge, which I sold to another guy, the Diamondback, will do Damascus very well, will do forge welding, very high temperatures. This is, but for forging spikes, it depends on what you want to get into. There's really, and you'll find as many guys that'll say that they prefer gas. You have a lot of guys that prefer coal. You know, and the coal's a traditional way. It's the way it's been done forever, and it's what you have access to and what works for you. But coal gets hotter than even the best gas forges unless you have forced air blown into it. But it actually gets too hot in some cases. You have to be pretty good at tending your fire. You can actually burn or melt the steel. You'll burn it up. This, they said crappy forge, but you can set it and forget it. I can walk around and BS with all of you, and it's not going to burn up. We'll do, you know, especially if you set it right, you'll just keep it at that constant temperature. So probably do a little bit here. You can see the most garbage of anvils, but we will make this look like a knife. Right. You can see, like, as I was hammering that, I kind of got it into a little bit into the black range at the end, which is okay. It depends on what kind of steel. You know, the mini spikes actually aren't as good quality steel as the larger ones. They're kind of a soft steel and they're a little more forgiving. So you can hit them into the black heat and they'll be fine. But if you're working with something like S90V or even A2, something like that, it's going to shatter. Well, for one thing, it won't move. You know, you got to work that in a very strict temperature range. You just got to know the steel you're working with. For most carbon steels, even something like 1095, 1084, if you find leaf springs, those are 5160. You can hammer them into the black a little bit, you know, just for minor straightening and stuff, but you don't want to keep beating on them. Once they get down below about 1,000 degrees, which is a dull red to a black, you can stress fracture them. And on the same note, as I was mentioning with the coal forge, you don't want to get them too hot. You can burn them up. You can kind of cottage cheese them, we call it. The grain structure gets so big that it actually becomes porous and falls apart. So if you guys know anything about metallurgy, you know, steel has a grain and it responds to heat treatment in different ways, and the size of that grain and the configuration of the grain changes. I mean, there are professors that can talk your ear off on metallurgy, and it's important to learn enough of that to know what you're doing. But basically the way you're striking that steel and the way you're heating it is really going to affect the integrity of the metal. We'll show you here. We'll do a quick heat treat once we have this somewhat looking like a knife. Do a little grinding on it. But right now, I mean, I'm actually kind of glad that I'm forging this under such primitive conditions, because I can really show you, you know, the steps of the process, and show you that really the skill of the maker is more important than what tools the maker has. You can come around if you want to see. I know you guys are all behind me, so come around. Just try to not get hit with any sparks. Right now, I'm not worried about the shape of it. I'm just kind of flattening that out. Then we'll start to shape it sort of into a knife, and then we'll grind it. We'll profile grind it and then edge grind it. If you just come across a spike somewhere, sure. I mean, if you find, it doesn't have to be a spike. You find old springs, you find different metals, sure, you can forge them. So you can do some research online and find out like what steel it might be. Actually, Peter's over here, Peter's Heat Treating in Meadville will test steel. You can bring them for some small fee. I've done it before. You can bring them something and they shoot it with an X-ray gun. They'll tell you every chemical element. It's a spectroscopy process. They'll tell you every chemical element in that steel. So you find something, they can tell you if it's good steel or not. But you can look a lot of that stuff up online. Sure. I mean, the thing to watch out for with the spikes or with anything you find is, like, a lot of it can be rusty. It can be pitted really bad. So you might not be able to grind those pits out of a lot of the material. You can see this is a very primitive setup. You guys ever seen the guys in Nepal that make kukris sitting on the ground like this? They make the most incredible work with this, with an angle grinder. About a year ago, I went to Pakistan. I visited Wazirabad, the famous steel, Damascus steel. I don't know if you guys ever heard of that place. They're famous for Damascus steel. I started doing some work with these guys and importing some of their Damascus and leather goods, and got the chance to visit these guys. And I mean, they actually have fairly well-equipped shops. The conditions are crazy, but the things that those guys can do with very, very limited tools is astonishing. You know, it's all about the handwork. You know, they look at us and a lot of guys have the fanciest tools and can't make stuff. You know, but you have guys in Afghanistan that are making copies of, you know, assault rifles by hand with, you know, maybe a mill or a lathe, but there's like grinding and filing, and it's all precision work. So, you know, it really is about the skill and the craft. You can see it's a little off center here, so we're going to center that up. I'm not really worried about that yet, because we're just doing a rough thing here. We've got to offset that blade so it starts to look like a little bit of a knife blade. Now, usually you can see, like from my video, I'm twisting these. I don't really think I have the ability to do that here because I don't have a vice other than alcoholism. But I don't have any other vices here. Actually, I don't have that one here either. But that might change if I go to the firehouse later tonight. I might just have to live with this being untwisted for now. So we'll see. Probably should wear the safety glasses. I'm probably not the best person to preach about safety. I break a lot of the rules. I've done a lot of dangerous things and hurt myself. So don't do that. Well, with this, I'm kind of trying to keep it from falling off the cinder block. If I had a real anvil, I might do the same thing. It's kind of to keep your hammer, keep your rhythm so you don't get tennis elbow or screw up your wrist. You keep that rhythm, and then you can, a lot of forging work really has to do with your left hand more than your right. If you pay attention next time I do it to how I'm holding the tongs, that'll be more helpful than watching what I'm doing with the hammer. I mean, you watch both, but you get the idea that, you know, that's very important. We're going to spread this part out a little bit more. I'm going to hit that corner. This is tough to do, man, when you're working with absolutely nothing. Try to make something that looks like a bit of a knife. We're going to do it. Okay? Okay. I'm going to make this one a little longer and skinnier, I think, than the last one. And we'll draw that tip out. Every time I'm hitting on one side, I'm going to hit the other side. One side, other side, one side, like this. That way, I can control the deformation of the metal. If I start to fold it over, I get kind of a fish lip effect, and where the metal is actually hammered out more and upset on the edge, and it starts to fold in on itself. But if I can flip that tong hand horizontal to vertical and straighten these little things out as I go, it helps me to control the process. You guys have probably seen, like, obviously you have some interest in it, so seen like some of the Facebook groups. You know, I got into this a long time ago, like before it was considered cool, and there wasn't that many resources. I mean, there was internet. I'm not that old, but now, like, there's so much information out there about it. You can really find out a lot about the craft. A lot of that information is bad, though, so you have to kind of take it all with a grain of salt. You watch, you see, you might see something that I'm doing that I'm doing right. You might see something I'm doing wrong. You have to pick and choose and see what works for you. You know, experiment. Also, what works with your tools and your skill level and your experience. You see how I'm shaping that tip. You see, I'm hitting it not just one side. I want to keep it straight by hitting both sides at the same time. So now I'm starting to get a little bit of a knife, but we're going to make that, I might do a little bit of an upward curve on that, almost like a Persian style or something, or like a fillet knife. And then we'll grind it, and we'll try to make it look good. Any more questions? Any other questions? I'm all fired up about this, man. I did this like on the shortest of notice, and I'm very glad that I'm doing it, because once you get me going, I get fired up.
The quenching, they show it done with water and oil, and what's the difference? Why would you use oil?
Some steels respond differently to different speeds of quenching. The steel doesn't know what you're quenching it in. It's responding to how fast it's cooling down, the coefficient of cooling. So if you do any tool and die work, you'd be familiar with the different designations for types of steel, like W1, W2, A2, O1, D2. Those have to do with how they're quenched. W1 would be water quench steel, whereas O1 or A1 or A2 be oil or air quench. Air quench steel you don't have to quench theoretically in anything. You can take it out of the fire and wave it around. The air will cool it fast enough. But that has to do with the molecular structure of the metal. The carbon forms a solution in the matrix of the iron, which basically, if you picture, the simplest way to explain it would be almost like sugar cubes. It's almost a kind of a square structure. And when you let that steel cool at a natural rate, okay, the carbon separates along the grain boundaries. So it finds the easiest place to go as the iron recrystallizes from a plastic semi-liquid form. The iron wants to recrystallize. The carbon, it's obviously more complicated than this because you have more than just iron and carbon. You have different alloys that interact in different complex ways, and people have PhDs in it. But this is the basic explanation. If the steel is allowed to cool naturally below the quenching speed, that carbon's going to separate out, find the easiest place to go, and the result is the steel isn't going to really be under a lot of stress at a crystalline level, so it's going to be fairly malleable and soft. If you quench that steel, you get that stuff into solution. All the elements, the various elements are kind of mixing around and they're sliding over one another, and you freeze that. Those carbon and to a lesser extent other alloying elements are going to find places to go, and it's going to be cooling so fast that they can't find the most effective place, that they can't find the easiest place to fit. So they fit in places that cause those crystals to put stress and pressure on each other, and they crystallize in a way that makes that steel under stress, which makes it brittle and makes it hard. Okay? For some steels, you want to actually temper it back, draw the temper back after you've quenched it, because if you leave it as quenched, it's actually going to be too brittle. You need to heat that up again to a lower temperature to let some of that carbon go back into, find a more relaxed position, but not all of it, and that way you still maintain the strength, but you kind of dial it back a little bit. You can talk to these guys here at Peter's Heat Treating in Meadville. They'll talk your ear off. Brad Stallsmith, he heat treats knives for the best makers in the world. I mean, he's an awesome guy, and he's probably the most knowledgeable person I know about this subject. But that's the long, short answer to your question. That's probably pretty hot now. Oh, I don't know if we can use these. Yeah, those tongs are a little bit, they don't grab it right. So yeah, we'll make something that looks kind of a little bit more elongated maybe. You know, I can't really do a lot with the situation I'm in here, but we'll try to do something cool. All right, we're going to do that, and then I'm just going to take that back a little bit, give that a little bit of sweep, and then I'm ready for grinding once I make sure it's straight. I mean, for the purpose of demonstration, I'm winging it, man. I don't know. When I do it in my shop, I don't forge them real close to shape, generally, unless I have to, unless there's some reason or there's a curve in it. I have some really good grinding equipment, and I'm actually better on the grinder than I am as a smith. I mean, I do most of my work on a big power hammer, big forging hammer. I can forge a knife in a couple of minutes, but it's fairly, I just want to make it bigger than my template. You know, I do a lot that's mass production, so I have templates and I need everyone to be exactly the same. So I'll just make everything 1/8 of an inch bigger than what I need. I don't really hammer the bevels in, there's no need to. As I'm grinding it on a 3 horsepower motor with a big stone wheel, it'll take me 2 minutes to grind that thing down, and then another few minutes to polish them out. And You know, so it's my style. You know, there's some guys that forge everything within, you know, they'll get it down to a 32nd of an inch on the edge, and they can do that, and that's the way they like to work. For me, that would take me longer to do. Easier for me to, they said it back in Sheffield, which is another big knife making city, forge thick and grind thin. So, you know, that's how they did it too back in the day. Everybody thinks that these swords were made by blacksmiths. They were made in factories. You know, they were made in, they had power hammers run by water wheels and stuff, and they did it in the most efficient industrial method that they could. And an awful lot of the work was done on these giant grinding stones. And these guys ground it, and if you would have seen the swords and the knives that they made in those days, you'd have sworn they were made on a CNC machine. I mean, they were perfect, you know? They weren't rough looking at all. This one will be rough looking because we're making it in a parking lot. But we'll see. All right, just want to get, problem is I don't really have a curved surface. Maybe the corner of this block will do. Usually I would be using the horn of my anvil. There we go. See that? Now you got a sweet looking curve on it. Just want to check straightness. Let's see how I did. Not bad. Let's see. We'll give it like one more straightening heat, make sure we're good. Then we can go to do grinding. I mean, this is even closer to shape than I would be forging them back home. I just pretty much flatten them out and cut them out. Unless I'm doing something that like Damascus would have to be, you know, it's a lot of forging work. I wish I could do some twisting here, but I don't think I can do a twist with no vise.
Now, are you presently a one-man show?
Sort of. I have a couple of part-time guys that help me out. I don't have any full-time workers yet, but I have some part-time guys, and like my leather stuff, I outsource all my leather work. So I have a local Amish guy that does some of my leather. I get some of my leather from Pakistan, and just different guys. I'm looking for a guy right now. If you guys know anybody that does Kydex work, I need to get somebody to do Kydex sheaths, because all the military guys want Kydex, but I don't know how to do it. All right, that's looking pretty decent. And I mean, that's literally just made from a track spike. There's nothing to it. That's a mine spike. All right, see what I did there? I had to get it in line. I'm trying to check and see if this is in line with the little kind of the way that these are drop forged in the factory. They have a kind of a line like a step here. I'm trying to get that parallel, get the blade in line with the little step. And that's actually, it's not bad. Can't be too much of a perfectionist when you're forging a knife in a parking lot. All right, this'll do. All right, don't walk on me here. Okay, good. We'll just give this a very quick polish, and then we'll put an edge on it, see how sharp we can get it. don't do that either. Or that. Almost ready to go here. Only reason I'm doing it sometimes towards me and sometimes away. You mean the grinder itself? Or do you mean the way I'm approaching this wheel? Because this is a very small setup and the wheel is so small that the motor housing gets in the way. So in some cases I have to do, ideally I would do both of them this way because it keeps my lines cleaner. But it doesn't, for this purpose, it doesn't really matter. And this is really the old school way of grinding. You know, this is the way the Asian guys do it, the Pakistanis, even the old English guys do it like this with these reverse wheels like this.
Does it help if it's continuing to get, if it gets wet?
Well, I'm just trying not to overheat it because you remember we just tempered it. So I don't want to burn out the temper. I don't want to see any color change in there. That is pretty good, I think. We'll just hit this, brush that part, and then we'll put the final edge on and we'll have a finished knife. I'm just trying to kind of hit the highlights on this brush wheel here. This is just like a Scotch-Brite. It's a Chinese knockoff Scotch-Brite wheel. And this. Now I'm going to put my edge on. Missing one set of bushings. It looks like this. You guys seen a, ah, here's one. Oh, that's an extra. Here we go. Okay. We'll put the final edge on and polish strop the edge, and then we should have a pretty sharp knife. This isn't the world's greatest steel. The mini spikes really aren't the best, but we should be able to get a pretty good edge on it. As long as we don't heat it up too much. And this is you know, there's an art to that. There's definitely a skill to sharpening knives. You can do it, I brought like a flat stone. You can do it on a flat stone like that. You can do it on a wheel, you can do it on a sanding belt. Everybody's got their own way of doing it. I like to go away from the edge and then toward the edge, and that helps me to take care of that burr. Knock that burr down, just going two directions. I'm putting a pretty fine edge on that. Actually want to make it a little bit less extreme angle because I don't think this steel will support it at that angle. Okay. All right, so we got a burr. When you're sharpening a knife, you know, you take it down on a rough grit like this until you feel that wire edge, that burr, where the metal's actually pushed over and rolled over. And then we'll go to the next, and in this case, final step. You can do a lot of, if you really want to make a sharp knife, you do 4, 5, 6 different steps. This will be good. This is a felt wheel with some really fine buffing rouge on it. It functions the same way as like a barber's strop would when he's stropping and honing that razor. And that should just kind of polish out the grinding scratches. This wheel doesn't really exactly fit on this machine, I found. So don't try this at home. I mean, yeah, right. You can work with very simple tools, you know, but there's dangers involved of doing it this way, you know. And you see, I'm only going away from the edge this time. I'm never going to put that. That could be really dangerous. You can cut that felt wheel and that knife will go flying. I did it one time. A knife hit me in the face while I was polishing like this, and I made the mistake of going into it like that, and I have a scar on my face from that. It was really bad. Now let's see if we can find a little, something like a stick or a piece of wood, just to knock whatever's left of that burr off. You can do like this, that's fine. We'll just keep working that a little bit more. Oh yeah, that'll shave. You can shave with that. So there you go. There's a knife made from a railroad spike in a parking lot.
Well, thanks, Andy. That was really fascinating. I thought about that one myself, and I may want to give that a try someday. Of course, there's a little bit of equipment you need to get involved in blacksmithing, but Andy's got quite the setup, and I was very impressed with the project he worked on today. So I guess you reach him by Facebook, Andy Alm Custom Knives on Facebook. So, well, thanks everyone for joining us today on Crawford County Outdoors. We'll talk to you next time.